So in this video, we're going to talk about graphing a quadratic that has all three terms. It has an ax squared plus bx plus c. So here in this case, ax squared plus bx plus c. So the first thing I'm going to suggest that you always do is you identify your a, your b, and your c. So for a is always the first term that's in front of your x squared term. So a equals 1 in this case. B equals your second term, or your linear term, which is -4. And C is always your constant, -1. All right, so now that you've done that, you're going to use a very important formula, and that's the axis of symmetry formula. The axis of symmetry formula is -b over 2a. So x equals -b over 2a. Now that we've identified our a and our b and our c, it's super easy to just plug those into this equation. So we've got negative, and then b in this case is -4, so -4 over 2 times, and a in this case is 1. So we've got a double negative there. We know double negatives turn things positive. So we've got 4 over 2, which is 2. So my axis of symmetry is x equals 2. On my graph, I am going to put a dotted line on 2. And because our axis of symmetry is a vertical line, that is why we're putting a dotted line on -2. I like to be able to see that dotted line so that I know what I need to reflect across, because an axis of symmetry allows us to reflect points across it evenly. Now that I have that 2, I'm going to take that 2 to plug it in to see where my vertex is, because I know that my vertex always lies on my axis of symmetry. So anytime I see an x, I'm going to plug in a 2. So 2 squared is 4. -4 times 2 is -8 minus 1. So we've got 4 minus 8 is -4 minus 1, which is -5. So my vertex ordered pair is 2, -5. So on my graph here, I'm going to go down to -5, 1, 2, 3, 4, 5, and I'm going to put a dot on -5. Okay? So now, in order to be able to use that axis of symmetry to my benefit, I need to be able to identify my y-intercept. Your y-intercept is always your c term. So in our problem, our c term is -1. So I'm going to go on here, and I'm going to go to -1, and I'm going to put a dot on -1. That axis of symmetry is beautiful because it allows us to reflect that ordered pair over it. So if I'm reflecting this, I'm going 1, 2 to the axis of symmetry, then I'm going 1, 2 over the axis of symmetry. And then I always like to plug in at least one more point to see what it looks like to give me a really good shape. So I'm going to plug in -1 as well to see what that ordered pair will be. So f of -1 equals -1 squared minus 4 times -1 minus 1. So -1 squared is 1. -4 times -1 is +4 minus 1. So that would be 5 minus 1, which is 4. So my ordered pair would be -1, 4. So on my graph, I'm going to plot -1, +4, and then I'm going to make sure that that gets reflected. 1, 2, 3. So I'm going to go 1, 2, 3. And now I have enough points to be able to accurately draw this quadratic. There you go. So that's how you graph a quadratic using the axis of symmetry formula, your vertex, and your y-intercept.